There is another kind of product when working with vectors, and for instance, this is the cross or vector product, and it's called a cross product because if we have vector A and vector B and we multiply, the symbol we use is a cross, and it's going to be a vector because this will lead to a vector and not to a scalar, such that the answer, for instance, has a magnitude. For instance, let's call this C, and the magnitude is going to be calculated as the product of the two magnitudes of the original vectors times the sine of the angle between the original vectors. It also has a direction, and the direction is always perpendicular to the original vectors, perpendicular to vector A, which is the first vector, and vector B. And the sense is given by the so-called right hand rule, such that if we have, for instance, vector A here and vector V here, and of course there is an angle between both of them, and let's suppose that these vectors are in the xy plane, then the product could actually be a C vector that goes upwards, or it can actually go downwards. And the sense is going to be given, for instance, by the right hand rule, such that in this case, if we state A dot B, you input your right hand in A and close it towards B, and then C has to go towards the upwards direction. But if we put V dot A, you have to input your hand in B and close it towards A, and then C has to go towards the downward direction. Let's suppose, for instance, that the Z direction is towards outside of the screen or inside the screen. For instance, if we have A here and B here, you can input your hand in the A, for instance, and you have to close it towards the B direction, which will actually, your thumb will point towards outside the screen, which means that A cross B in this case goes towards the outside of the screen, while if you state V cross A, in that case it points towards the inside of the screen, because you have to close your hand. You input your hand in B and have to close towards the inside of A, and your thumb of the right hand is pointing towards the inside. So if you have two vectors with the components and you want to perform A cross B, then you have to build a matrix, and the matrix, for instance, you always input I, J, K at the beginning, and then AX, the components, that is, for instance, AX, AY, AZ, and VX, VY, and Vz, and the first thing that you are going to generate is the final component I, such that you are going to block whatever has to be with I, right? And then you are going to state, for instance, the product between these components, such that this is going to be AYVZ minus VYAZ, and that's the I component. Now, in order to perform the Y component, you start with a minus, and then you're going to block the Y line, and then do exactly the same product as a cross, AXBZ times BXAZ, such that the Y component is going to be AXBZ minus VXAZ in the J component. And of course there is a third component which you start with plus, and that's the k component. And of course once again you block the component z's, and then you're going to do exactly the same cross. Ax by minus bx ay, so this is going to be ax by minus bx ay, and that's in the k component, and you have generated at the very end a vector which has three components, and that's the story of the vector product.